Okay, so this week in Algebra 1, what we're going to do is do something a little bit more traditional as a lesson. I'm going to go through these notes in this video, and we're going to talk about function notation. So, um, function notation is something that we've kind of been touching on in different ways in the last few kind of um, online activities in this distance learning. Um, Now, I know this is going to be a little strange because I have, a handy little tablet and pen that you've seen me use in class all year. I got it from back from the school. But you probably don't have something like that, and that's okay. I'm going to use it to go through this, and then at the end, what I'm going to ask you to do is try some problems on your own. Like I said, in a kind of a traditional manner. Um, Try some problems on your own. So either find a pencil and paper to do those, or I'll try to kind of put them into the same online Desmos system that I've been using. So you can submit it either way. I'll let you do it either like on pencil and paper, and then just take a photo with your webcam. Same thing I'm using to show myself down here in the corner. You have a webcam on your Chromebooks, and you can just take a picture of it, or you can take a picture using your cell phone if you can do that, and upload it to Google Classroom. Or hopefully I'll have an online version that you can kind of answer there. So, okay, so what are we talking about this week? We're going to dive into function notation. What does it really mean, and how do we use it? So, as you can see, yeah, function notation, when it's written as an equation, is written like this. So it's got f parentheses x um, equals something else, which we can call it as y. And what this means is that x is our input. It's a little strange here to write. But yeah, x here is our input, and y is our output, or whatever it is on the other side of the equal sign is what our output is. And this is, as it says, it's read as f of x. F of x. This is how we would read this. So for example, here's a little reminder, or a little kind of example here, and we'll do some more. F parentheses -3 means -3 is the input, and that's what we're going to plug in for x, because x is typically our input variable. This is a little bit different. These two things are different. This statement, f of x equals -3, means that -3 is the output. Now it's on this side, and we're usually, when we've got something like this, we're looking for what would x have to be? What would the input have to be to get that? So let's do a couple of examples as a function notation as equations here. Scroll down. So here we've got an example. F of x equals 2x minus 3, right? So here's our example. Um, so this tells us how we're going to find our output based on whatever x is. F of -2. So how would we evaluate this? Well, this means that -2 is our x. This is our input, or x. So how do we find f of -2? Well, we're going to plug this -2 in wherever we see an x. So here in our output, 2x minus 3, we're going to have 2, and then I like to replace it with parentheses wherever the x's are. And inside those parentheses, maybe I'll change color here, we're going to put our input, which is -2. That's our input. I'll try to get better at these colors. So 2 times x, 2 times negative 2 minus 3. And then what do we get? What is our output? Well, 2 times negative 2, you could use a calculator if you want. But that's going to be, and there's a good calculator. Let me show you. If you don't have a calculator at home, you can always go to Desmos Scientific, and it will basically pull up a scientific calculator that you can use at home, anywhere. They also have an app for your phone, or I'm sure you guys have calculators on your phones in some form. But I could plug this in here, 2 times negative 2 minus 3, and it says, oh, there's my output, equals negative 7. So let me go back to here. So our output, what this equals, is negative 7. That's our answer. I'll just write here output just so we know. So remember, a function takes inputs. It's like a rule, right? It takes an input and it spits out one unique output. Let's do another one with this same function, f of 7. So what is this going to be? Well, we're going to take the same function here, f, which is 2x minus 3. So 2, and now what's our x? What's going to be in our parentheses here? I'll make this a different color. Our x here is 7. There's our input. That's our x. It's a little hard to use, but here's our x. 2x minus 3. So 2 times 7 minus 3. Right? We're taking our rule, which says whatever the input is, multiply it by 2, and then subtract 3. And what do we get? Well, 2 times 7 is 14, minus 3 is 11. And that's our output. That's our answer. Let's do one more. F of negative 4, just for practice here. Actually, why don't you go ahead, pause the video, and see if you could figure out mentally what this is. I'll give you a few minutes. In fact, let me put up a pause screen. Okay, so there you go. There's a pause screen. Take a few minutes and see if you can work that out. F of negative 4. What is this going to be? Okay, so hopefully you've thought about it. Let's go ahead and write this out. So we're going to have 2, like before, times x, which is negative 4. Remember, this is our x. So negative 4. Oh man, I really don't like this program. Minus 3. Well, 2 times negative 4 is negative 8. Minus 3, think about negatives adding together. Ooh, didn't like that one. And they just become more and more negative if we're adding two negatives. So that is a negative. I'm going to have to find a better program. We get negative 11 is our output. You have to be very careful here. Okay, so let's do another one. Let's do another example here. Here's a new function, k of x. And k of x has a different rule. It says, how do you find the output? Well, instead of multiplying by 2 times x, we're going to multiply by negative 7. Negative 7 times x plus 1. So let's evaluate a few different things. So k of 0, what does that mean? That means 0 is our x, right? Just one more, just kind of keep doing this. This is x. So we're going to plug that in for x. -7 times 0 plus 1. So -7 times 0, well, okay, that one's pretty easy, right? Anything times 0 is 0. So we get 0 plus 1 is just 1. That's our output. And if you don't like me circling these things, just send me a comment. Let me know. How about k of -1? Same function, just -1 now instead is our x instead of 0. So we're going to plug that in where we see x here. So -7 times x is -1 plus 1. And again, if you don't forgive me for my handwriting, first time I'm using this program, it's going to take me some practice. -7 times -1. Oh, this is a good one. Reminder, what's a negative times a negative? We get a positive, right? So we get +7 plus 1, and we get 8 as our output. So it really doesn't like me writing 8s. Okay, last but not least, k of 5. What are we going to get there? See if you can work it out in your head. Pause the video and see if you can figure this out. Okay, so hopefully you've thought about it. We're going to get, let's see, did you come up with -7 times 5? That is supposed to be a 5. Come on, program. Oh my god, it looks like an 8. I'm sorry. Plus 1. So -7 times 5, that's a good multiplication table. 7 times 5 is 35. -35 plus 1 puts us a little bit less negative with this plus 1, so -34 is our output. Oh my god. Alright, you know what, let me erase this. Getting frustrated with this thing. Come on. Alright, one more time here. I'm gonna have to download some other software, I think. Whoa, come on. Still did not like this. Yeah, definitely gonna have to go back to my old Mimeo software next time. But we get equals -34. I just have to be a little slower on this. And that's our output. Okay, so let's take a look at this next example. So these ones were pretty simple, right? We're just plugging in numbers for x. What about in these next two examples? Sometimes in an equation, we have multiple x's. What do we do when there's multiple x's in the equation? Well, we simply replace both values of x. Anywhere we see an x, that's what we're going to replace with our input. Remember, this is our input, our x. So if we see it more than once in the equation, we're just going to replace it every time we see it. So here, if we've got h of -3, what's that? Well, we've got -3 is our x here. It says, what do we do with x? We square it. Okay, so we're going to square that. Then we're going to also add on -3 times x again. Oh, okay, so, well, what's going to go in the x again? The same number that's our x here, -3. Maybe I'll just do one example of this. Plus 5. So we're not finished with our rule because our rule has plus 5 here. And what do we get as in our output? Again, we could do this out mentally, or maybe just plug it into a calculator. So let me say -3 squared. What do we get here? -3 squared minus 3 times -3 plus 5. Minus 3 times -3 plus 5. Okay, so our output is 23. And, to be honest with you, if you use a calculator, that's totally fine. Sometimes I like to use a calculator. I don't like to do this arithmetic in my head. And you can make a small error. It's easier to just let the calculator give you the answer. So 23 is our output. The answer is less important than writing this out and knowing where it comes from. So that's how we would deal with an equation with multiple x's in it. We would just replace anytime we see the x twice. Or anytime we see the x, we'd replace it with that number. Let's kind of skip ahead here. I'm going to kind of try to keep this video short. In fact, yeah, I'll just finish this page and then I will try to make this into a few small videos. So I think this will be the end of part 1 on just evaluating functions as equations. All right, so feel free to look this over. I'll try to post it. It looks a little funky, I know, and I'll post part 2 soon.